In this video, we're going to be looking at permutations with repetition. So what that means is that some of our objects are the same. So if we look at the letters E, E, and Y, well, two of those are E's, and they're the same. And so if we're looking at the number of ways to arrange those three letters, well, if we have, say, E, E, Y, and then we switch the two E's around, that's really still E, E, Y. That's no different. So we have to be a bit more careful if we have repetition when we're calculating permutations. So in part A here, for example 6, let's first pretend that the E's are different from each other. So I'm actually going to call one of them E1 and the other one E2, just to make them different from each other. So we could have E1, E2, and then Y, or we could switch those E's around and then get E2, E1, Y, and these are different from each other if we're saying that the E's are different from each other. Another way we could arrange these, we could have, say, the Y in the middle, and then we could, of course, switch the E's around. And then we could have the Y at the beginning. And then switch the E's around. And then this is all 6 ways that we can have of arranging those 3 things. Now we could have calculated that there's going to be 6 if we had done the permutation calculations. So we've got 3 spots. For the first spot, we could choose any of the 3 letters, E1, E2, or Y. For the second spot, we could choose any of the 2 letters left. And then for the third spot, we've only got 1 option left. Multiply these together and you get 6. That tells us that there's going to be 6 different ways to arrange these 3 letters. But if we don't consider those E's to be different from each other, if we just say, well, they're E's, and so if we switch them around, there's no difference. So EEY is the same thing as if we switch the E's and get EEY. So that would mean that these 2 are really the same if we're not counting the E's to be different. These 2 would really be the same, and these 2 would really be the same. And so we don't have 6 this time. We actually only have 3 distinguishable permutations. Distinguishable means that we can make a distinction between, say, EEY and EYE, but we can't make a distinction between EEY and EEY if we're not counting the E's to be different things. So there's no difference between these 2. They're indistinguishable if we're not counting the E's as different things. And so really the only options we have then are EEY, EYE, and then YEE. And those are the only 3 options if we're talking about the E's being interchangeable. If we can switch these E's around, there's no difference then. So what we're going to do then is we have to actually divide by the number of ways to arrange those E's. So we can do the same calculation. So we've got 3 options for the first spot, 2 options for the second spot, 1 option for the last spot. But then what we need to do is uncount some of these extras that we've counted. So if we do this, we've counted too many things because we've counted these E's being this way and then also swapped around. We've counted these E's being like this and also swapped around. But if it doesn't matter if we swap them, then what we need to do is divide off the number of ways to arrange these E's. Well, as we learned in the last video, the number of ways to arrange some number of objects is that number factorial. So if we have 2 E's, we're going to divide by 2 factorial, which is 2 times 1, so that's 2. And so what we get is 6 over 2, which is 3. So there's a formula for this. Personally, I don't really like the formula, but again, it's here if you're wanting to use it. But what this says is that if we want to know the number of distinguishable permutations, what we're going to do is take n factorial, which again for normal permutation, and if you're wanting to know the number of ways to arrange some number of objects, we take that number factorial. But then if we have repetition, we need to divide by all of the repetition. So that's what this S1 factorial, S2 factorial, sk factorial. So if we have repeated, say, E's here, we're going to divide by the number of ways to arrange those E's. And we do that for each thing that is repeated. So the S1, S2, and all the other things that we could divide by, this just depends on how many things you have that are repeated. So this would be 1 repeated object, divide by the number of ways to arrange that repeated object. Same thing for if you have another repeated object, or another, and so on. All right, so let's do these with some words. So say we want to take these letters in Pinnacle and find out the total number of ways that we could arrange those letters. And again, we've got 2 n's here, so we have some repetition, and so we're going to need to be careful as we do this calculation. So first of all, we have 1, 2, 3, 4, 5, 6, 7, 8 letters. And so the number of ways to arrange those letters is going to be 8 factorial. But 2 of them are n's. And so we're going to need to divide that by the number of ways to arrange those n's, which is 2 factorial. And so if we work this out, 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And that's 40320. Divide that by 2 factorial, which is 2 times 1, which is 2. Divide that out, and we get 20160. So about 20,000 ways to arrange these letters. Now let's go to Tallahassee. So this one you can see there's more than one repeated letter. We've got 2 L's, 2 S's, 2 E's, and 3 A's. So all 3 of those A's. So we're going to have to be a bit more careful. We're going to have to divide off the repetition for all of those letters. So the total number of letters we have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the total number of ways to arrange those, if they were all different, would be 11 factorial. But since we have repetition, we're going to need to uncount some of these. So again, since we're counting with multiplication now, to uncount things, we need to divide. So division undoes multiplication. So if we're counting with multiplication, to uncount things, we need to divide. So we need to uncount the repetition. So it doesn't matter what order those L's are in. So we need to divide by the number of ways to arrange 2 letters, 2 L's. That's 2 factorial. It doesn't matter what order these S's are in. So we need to divide by the number of ways to arrange 2 S's, which is 2 factorial. And it doesn't matter what order those E's are in. So we need to divide by the number of ways to arrange 2 E's, which is 2 factorial. And then again, it doesn't matter what order those 3 A's are in. So we're going to need to divide by the number of ways to arrange 3 A's, which is 3 factorial. If you work that out, then what you're going to get, 11 factorial is 399,16800. Divide that by 2 factorial is 2 times 2 times 2 times, and then 3 factorial is 6. Multiply that out, we get 48. And so then we're going to take 11 factorial, that big number, and divide it by 48. And what we get is 831,600, so about 800,000 different ways.